Question 18 is from 2023, the external exam in paper 2. It's an absolute gem. This question lends itself really well to a tech active response. Um, and I wanted to kind of engage with it pretty much totally on the calculator. Now you'll see there's things that I need to write down, but essentially, what can I do that the calculator will just nail the whole thing? Now, a company makes windows using glass, mass of 5.6 kilograms. Okay. Customer orders an unusual window in a partial parabolic shape as shown. Determine the mass of the window. Now, my approach always is whenever they're giving me a diagram and I need to define some variables, I'm going to define them on the diagram rather than actually writing out what I'm defining it as. And certainly in this case, what works really well is that since it's parabolic, for most people, finding the equation of the parabola is going to be the approach that they use. Certainly, it's the one that I'm going to use here as well. Um, and for many of my students, drawing the y-axis right down the middle would be the simplest way for them to deal with it, because it gives the top point then as being 0, 12. This point was negative 4, 0, and this point was 4, 0. Now, for many students, the turning point form of a parabola is in fact their approach, although both the turning point form and the intercept form will work in this situation. So either one of those is actually certainly accessible. However, I'm going to go instead to a different section of the calculator, and that is I'm actually going to use what's called quadratic regression. So by telling the calculator the 3 points that I have and performing quadratic regression, it will actually tell me what the equation is. Now, this has an advantage in a couple of ways. I'm going to actually show you how to do that. So if we go to Stat and Edit, and then enter in the y values that, or the x values that I have. So certainly they are negative 4, 0, and 4. And then the y values, of course, that go with that are 0, 12, and 0. Um, at that point, going to stat again, only this time I'm actually wanting to calculate. And one of the options is quadratic regression, which is option 5. So I'm selecting that. The x values are in list 1, yes. The y values list in list 2, yes. Frequency I don't care about. Storing the required equation. I want the calculator to remember the equation. So I'm going to go to alpha F4, which actually says, okay, where do you want to put it? And I'm putting it in as Y1. And then, of course, I'm just going to execute that. So I'm asking the calculator to execute that. Now, this is in the calculate screen, so it actually just comes back and gives me this. And certainly what I did at that point was write those values down because it's an indication of what I'm actually doing. I wrote the word quadrag there because that's what I did. And that's how the answer came out. Certainly, I then wanted to, now but stored somewhere in the calculator because I told it to, is in fact the function, negative 0.75x squared plus 0x plus 12. So that's all recorded in there. And I recorded it as y1 as well. And then if we go on then in the question, what I needed to do at that point was to find the area of the parabola. And so my approach was simply to, well, given where I am, probably the easiest thing to do is to simply say calculate the integral, which is option 7. The lower limit is negative 4. So I'm just going to tell it, okay, negative 4, do that. And option 4 is, of course, the upper limit. And so the calculator then goes away and does that and comes back with the answer being 64. Now, notice in the solution over here, I wrote AP. Now, I didn't define what I meant by that, but I got my fingers crossed that the markers are going to recognize what I actually did. I certainly integrated the function I had. And I defined what I meant by y1. I'd actually deliberately written y1. That's the notation in my calculator. So I didn't call it f of x, but I could have, but it seemed simpler if I didn't, if I just called it what the calculator said it was. And then I did the integration and the answer was 64. So now, if we moved on from there, then of course what there was to do was to go back to the question and actually calculate the area, well, the area of the triangle, because I needed to subtract that from the area of the parabola. And what I then did was I basically went straight to the cosine rule. Um, the cosine rule is my preferred place to go almost all the time. There are very few situations where I apply the sine rule. And certainly in this case, there's just nowhere where you could apply the sine rule. It is the cosine rule, absolutely. Um, Now, I didn't actually say cosine rule and or even write it out. And occasionally, of course, there are times when I would prefer to write cosine rule, but it pretty much what's going to happen is the cosine rules on the formula sheet. The QCAA are not going to give you marks for indicating something which is actually on the formula sheet. So pretty much writing the cosine rule just helps the marker see what you're doing. This is certainly a straight recognition of how the cosine rule applies. And notice I defined what I meant by alpha up in the diagram. Drawing on the diagram has the power that you're actually able to define variables and all of that directly on the diagram. In fact, here this is x, this is y, this is alpha, and it's clear to the markers that's exactly what you're doing. Now, then I went straight to the solver, and now while it's not obvious, I didn't say I used the solver. There's value nevertheless in and sometimes in writing that. But what's more significant here is that I came back and said, therefore, alpha must be this. Now, the thing to understand about the cosine rule as well, there was only ever going to be one answer between 0 and 180. So alpha isn't actually an angle in a triangle, so I didn't have any difficulty establishing what the correct answer was, because the cosine rule was solving the cosine rule is only ever going to give me one value. And then I went straight to the calculating the area using a half BC sine A, which I didn't really write. I simply just said that means 8 and 9 are the two sides that are next to the angle. So it's a half 8, 9 sine of alpha. Now notice I didn't write out 48.189. I simply said sine of alpha. But since I'd already said what it was, that wasn't a problem. It was actually executable and came out as that. So I wanted to actually go back then, so we'll quit out of that and we'll actually execute that on the calculator. So this is a solve, so go to math and the numeric solver. So we're in the solver now, and we need the answer to come out as 7 squared. Now, temptation is to write 49, and I'm going to do that because I know what 7 squared is. That's tempting as well. 9 squared is 81. Plus, and of course, this is tempting as well. 8 squared is 64. Now, then I'm actually just going to type what's there, although 2 times, and I do know that 9 eighths are 72, so I could actually just write that. And then press times, and it's the cosine that I want of alpha. Now, then, let's just see. So it's alpha, so I actually want, I'm just going to call it A because I don't really have an alpha that I can put. So I'm just going to put A. And I'm going to close the bracket then and say, okay, execute that. And then horror of horrors, I'm actually in radian mode. However, I'm just going to put 1 there. 1 radian might be the answer. And I could execute that and it comes back and says it's 0.841. Now, is that a problem? Well, no, because in fact, by the way, had I done it in degree mode, it would have come out as 48.189. Coming out this way is not a problem because then if I exit this, it still knows what A is. So if I asked it what alpha A is, it will tell me that it's 0.89. I'm not going to convert because as if I execute the next line, which is actually basically a half, which is 0.5, times multiplied by 8 nines are 72, times the sine of the angle that I just got, which I could just put answer there. That's certainly, I could put answer or I could put A. It's not going to make a lot of difference which way I do that. and execute that, and it comes back and says, okay, the area is 26.8328. So all of those answers have showed up there. So, and then, of course, the next part of the question simply requires me to calculate what AP minus AT is. Now, not a difficult thing to do there, because I already know that 64 is the value of AP, and all I'm doing is subtracting what that answer is. So I could either type answer or get answer, or I could simply pick it up and put it there, in which case it's going to execute that and say 37.167. Then, of course, I'm wanting to multiply that answer by 5.6 because that's the area of the glass, but I need to know, in the question it said something about finding the mass. So I'm multiplying. So if I just press multiply, it's going to pull that answer, and then it's 5.6, and it's basically going to deal and give me 208.136. Now, I'm not looking for a lot of decimal places here, because in the context of the question, you can see that being precise about something like this seems kind of irrelevant. We're talking about a practical situation. The glass, the 5.6 was the level of accuracy that they're willing to give in the question. So I'm saying 208 is going to deal. At worst case, I might give one decimal place, but no, it doesn't seem relevant. Anyway, I'm done on that question. If we actually clear that off then. And look, there's something to also recognize is that everything I did is all back there. So I could actually scroll back if I needed to look at anything. Now, let's just quit out of that and clear the screen as well. And we're going to move on to the next question. Now, this question is an older question as well. I think this one dates from like the mock paper in 2020 or something like that. It's a way back. And so one of the things that happened in 2020 and even earlier in terms of the mock papers and that sort of thing was the number of marks allocated to questions wasn't necessarily what we would do today. So for this question, 7 marks seems like a lot when you see what there actually is to do. Again, with the cosine rule, I'm saying, okay, the cosine rule is going to bring together all of the information that I've got here. I've got a single angle and I've got 3 sides. The cosine rule does that. So the question's asking me for the area of the triangle. Curiously, it actually called it A, but we can call it A as well. In fact, all of the variables I need, P and A, are all in the question. So I can just roll with what they've given us. Now, initially, as I started this question, I didn't write as I did on the diagram that P plus 3 was greater than 0 and therefore P was greater than -3. And I didn't write this either, that 8P plus 6 had to be greater than 0. It was the side of a triangle, and therefore that meant that P was greater than -0.75. I didn't do that initially. I actually came back to do that when I realized what was happening. So I applied the cosine rule, and basically that meant that P plus 3 squared was equal to that. So I just did all that and asked the calculator to solve it. Now I came back with a negative number, and suddenly I went, whoa. In fact, I discovered there were 2 negative numbers. And what was there to do with that? So I went back and took a look and said, okay, if P actually had to be greater than -0.75 was something that I could then see from this here. This didn't give me much because both the values I had were greater than -3, but this told the whole picture. So the other negative number I didn't care about. So I just rejected it. I said, because P is greater than that, any other solutions to this don't care. And all there was to do at that point was to go and actually calculate the area. And again, I'm not stating the formula. And perhaps that's something, given the question's worth 7 marks, perhaps I could have. However, as I said, in hindsight, the QCAA is not awarding marks for really writing down what the formula is when it's actually on the formula sheet anyway. So to execute that, it was simply a half times 0.7. And of course, at this stage, my calculator knew that the value of P was actually this. So plus 6 greater than sine of 0.8. And of course, the calculator had to be in radian mode because the 0.8 wasn't in degrees, it had to be in radians. And so the answer came out that the area was in fact 0.77 square units. Okay, so I'm actually going to go to executing that on the calculator. And basically, when I did these, p is greater than -3, I did that in my head. And pretty much this one I did by hand as well. There didn't seem to be a lot of point in entering that in the calculator. However, if we go into math and the numeric solver is saying, okay, what we need here is brackets P, which is, and I'm always using the pronumerals that they actually give me as much as I can. There'll be times when I don't, but like X will sometimes show up. But pretty much all I'm doing is I want P plus 3 squared, because the one opposite the angle is P plus 3, so that's the one that's by itself. And then, of course, if we clear that out, and what we want here is 0.7 being squared plus, whoa, okay, 8p alpha p plus 6, and that's squared as well, which is there. Subtract 2 times 0.7 times, and this one will be in brackets again, so it'll be bracket 8 alpha p plus 6, and that's then multiplied by, so times the cosine of 0.8. Now, calculators in radian mode. Every time you're doing trigonometry in this, check what mode you're in. Most of the time you'll be in radian mode anyway, because that's a lot of the function work you do will be in radians. In fact, all of the function work you do will be in radians. However, yeah, always check. Now, then I'm going to, now what am I doing? I actually need to solve that. It's not so much a graph, it's that OK is actually this button here on the calculator. And so I'm selecting that. P, I have no idea what I'm looking for here. So in fact, I'm inclined to leave it at 0 and see what happens. And now if I do that, it comes back with negative 0.3658. I was kind of like, okay, what does that mean? Because I didn't realize P was even potentially a negative number initially. So I then went back and doctored all of this up to see what was happening. And this value was certainly greater than negative 0.75, but I wanted to find out where the other one was. So pretty much I typed in 3 to see what would happen then. I went and said, okay, solve that. And it came back with the same value. And I said, oh, okay, what am I going to do? So it was then I tried -3 to see what would happen there. Now, it was never going to be -3, but I needed to solve and see what was actually happening. And it came back with negative 0.9, which I now know is not it, because it actually is too far in the negative direction. I needed P to be greater than negative 0.75. So at that point, there was to go back and find the other value because I've now lost it. So it was that if I went back to 0, it's certainly going to do that. Came back with the value. So now if we quit out of that, we now actually have the value of P. If we needed to just reassure ourselves that we had it, alpha P is in fact right there. It's negative 0.3658. Now, all we then had to do was calculate the area, which was certainly going to be a half, which I could do this way. I could also actually just type in 0.5. That's certainly an option as well. A half, and that was multiplied by 0.7, and that's then multiplied by brackets 8 alpha P plus 6, close bracket, multiplied by the sine of 0.8. So it's sine 0.8 and execute that. And of course, it comes back with 0.77, and that's 0.77 square units. That kind of was a little bit of a worry initially when I thought, gee, that's a small number. Except when I looked at the size and I thought, okay, 0.7 is actually pretty small. And the angle of 0.8 radians, well, 1 radian is 57 degrees, so 0.8 is going to be less than that. Yeah, maybe it's okay. And that was all I could do, was just leave it at that point because I didn't have any way of checking it any further. Um, so that's that. So I'm saying done on that question as well. Thank you for listening.